Hello everyone, welcome back. Today we will look into the Leetcode easy level problem called valid parenthesis. Let's understand the problem statement. So the problem statement says that we have given a string s as an input, and this input string will only contain these characters. So what are these characters? It is open and closed round bracket, open and closed curly bracket, and open and closed square bracket. We need to determine whether that input string is valid or not. The input string is valid if the open brackets must be closed by the same type of bracket. So if there is an open bracket of type round, it should be closed by the round bracket only. The second rule is open brackets must be closed in a correct order. So the bracket which is open recently, it should be closed before, and that order needs to be maintained. The second rule is every closed bracket has a corresponding open bracket of same type. Means the bracket should be there in a pairs only. Like we can't have just open bracket or we can't have just closed bracket. Let's understand this in detail with example. Let's say this is our input string s. If we carefully observe the string, we can say that it is following all the three rules to make it a valid parenthesis string. So let's see how. If you see the first rule, for every open bracket, there needs to be closing bracket of same type. And you can see this is true for each open bracket, right? And the second rule is that the open brackets must be closed in order. For example, if you see this curly bracket which was open late was closed first, and then the previous open bracket which is square was closed, and like this order was followed. And the third rule is that every open bracket must have the closing bracket. So we can see every open bracket have a closing bracket for it. So it is following all the rules. That's why it is a valid parenthesis string. Let's understand in much detail. So if when we see the last open bracket, right, which is curly bracket, and when we observe the closing bracket, we check what is the last open bracket, which is the curly bracket. So it is of same type, so which is good. Now we need to check the previous open bracket, which is the square bracket. Now there is a closing square bracket, so it is correct. Now we need to check the previous open bracket, which is round bracket. It is also correct. And like this, we check for every open bracket whenever we see any closing bracket. So this is how this string is basically following all the rules, and it is making the valid parenthesis string. So what did we observe here? Last open bracket should be closed first, right? Because the last open bracket, which is curly bracket, was closed, and then the previous bracket, which was square bracket, was closed. So the last open bracket should be closed first. We need to keep track of open brackets. Why? Because once this curly bracket is closed, we need to check what is the previous open bracket. So we need to keep the track so that we can backtrack to the previous open bracket. So what two properties we are seeing here? One is last in, first out, means last open bracket, check the close bracket first, and then backtrack, basically going back to the previous open bracket. So which data structure provides these two capabilities, last in, first out, and backtrack? It is a stack. So let's understand how we can solve this using a stack data structure. So if you see this string, if we start parsing this string, so we will keep pushing the open brackets to the stack because we need to keep track of open brackets. Now we'll continue that till we hit the closing bracket. So whenever we hit the close bracket, we need to check what was the last open bracket, which is the curly bracket. So it is of the same type. So continue. Now this is the closing square bracket. Check what is the open bracket now, which is a square bracket. So it is correct. So this is also correct, and like this we completed the input parsing, and stack is also empty. What does that mean? The parsing of the input is done, stack is empty. It means that there was a close bracket for every open bracket. So it is a valid parenthesis string. Let's understand this with one more example. So if we start parsing the string, we'll put each open bracket to the stack, and as we see the closing bracket, we check the top of the stack. It means the last open bracket, and if it is of same type, then continue. Then push the open bracket and check. Whenever we see the closing bracket, we check the last open bracket and close it if it is the same type. And if we complete the parsing and stack is empty, it means valid parenthesis. If there is some string on a stack, or if we see that whichever the closing bracket we see, and if we see the last open bracket is of not same type, it means that it is not a valid parenthesis string. Let's understand the implementation of this approach. This is the implementation in Java. So you can see we have declared a stack here. We are parsing the input string using for loop. If the character is of type opening bracket, we are pushing it to the stack. If the character is of type closing bracket, then check whether stack is empty or not. If the stack is empty, it means for the closing bracket, which is present in character C, we haven't seen an opening bracket for that. It means that return false. If we have observed the closing bracket of type round, then the last open bracket from stack top should be of type round only. If the closing bracket is of type square, then the last open bracket should be square only. And if the closing bracket is of type curly, then the last open bracket should be of type curly only. Otherwise, return false. Once the parsing is completed, we need to check stack is empty or not. If we completed the parsing and stack is empty, it means that we have found for every open bracket, we have found the close bracket. That's why stack is empty. Then only we need to return true. So what is the time complexity of this solution? We can see that we are parsing the string only once using this for loop. So let's say if the number of characters in a string is n, then the complexity of this solution is O of n, because we are parsing till the number of characters only in the string. So let's submit this. So you can see we have submitted this solution successfully with O of n complexity. If you like the video, please share and subscribe. Thank you so much.